Alright guys, I got some weird math for you. I want to try to tie together the stuff we did today. So, suppose we have x1, y1, and x2, y2. Now, I had said that the midpoint will be equidistant from these 2 points, but it's not sufficient. I mean, that's necessary, but it's not sufficient for it to be the midpoint. That's a necessary condition, but there are other points that are equidistant. For example, this point right here, I'll just label it xy because I'm allowing it to change. But that point can be equidistant, right? But it's not the midpoint. But I just want to play around with this because, so what other points was, like what's the conditions on x and y that would make it equidistant from these two? So to start this off, we're just going to say, well, this distance equals this distance, but it's easier to talk about the square distance, so we don't have any square roots. So the square distance between these 2 points is going to be equal to the square distance between these 2 points. And some pretty amazing things happen when you do that. So we'll do x1 minus x squared plus y1 minus y squared, this square distance, must be equal to x2 minus x squared plus y2 minus y squared. Okay. So what can we do with this? I mean, we could expand everything out. I don't know if that's worth doing. What I'm inclined to do is gather the ones that have x's together. So I'm going to subtract this and I'm going to subtract that. So we have x1 minus x squared minus this. And then we have this minus this. Okay, that's got to be true, right? Now, if you have a square minus a square, you can use the difference of squares formula to factor this. So imagine this thing here being a, and this thing here being b. So this is a squared plus b squared. A squared plus b squared factors into, a plus b times a minus b. Okay, FOIL that out and you'll get this. So that being the case, I'm going to write this thing as the first plus the second, so x1 minus x plus this x2 minus x times a minus b, so x1 minus x minus x2 plus x. And something very similar happens over here. It's the first 2 plus the second 2 times the first 2 minus these. So that's how you can factor all that. And now in here we have the sum of x1 and x2 minus 2 of these x's. So x1 plus x2 minus 2 of the x's. Here the x's cancel. So we have x1 minus x2. And then over here something kind of like that happens. We get y1 plus y2 minus 2y. And then we get y2 minus y1. So they're slightly different because this is y1 minus y2, that's y2 minus y1. Okay, so I suppose now what I'll do, because ultimately we want to solve for y, because that's how you figure out what you're dealing with. So I'm going to distribute this. You see how I can just use the associative property to kind of bracket these off and bracket these off? So I'm going to distribute this into the first and then into the second. So if I distribute it into the first, I get x1 plus x2 times x1 minus x2 minus 2x times x1 minus x2. And here I'm getting, if I distribute this into there, I get y1 plus y2 times y2 minus y1 minus 2y times y2 minus y1. I know this is probably pretty boring and then weird, but this is actually going to be amazing. So I'm going to add this to get it by itself and get rid of everything over here. So adding that gives me 2y times y2 minus y1 equals, if I add that, I get 2x times x1 minus x2. I can then subtract that, x1 plus x2 times x1 minus x2, and then I have this over here still. Now to solve for y, what I'm going to do is divide by 2 in this. So y equals, the 2's cancel on this, and I get this, some multiple of x. What I get is x1 minus x2 over y2 minus y1 x. Right, the 2's canceled. And over here, I have this minus this. So y1 plus y2 times y2 minus y1 minus x1 plus x2 times x1 minus x2 all over 2 times y2 minus y1. Does that make sense? Alright. Now this is actually going to be interesting. So I can split this into two fractions now. I guess I should have done that originally. I could have just split it into two fractions. But look at this thing. If I take the reciprocal of it, then the y's are on top of this one's, and then if I factor a negative out, it flips these around. So if I factor a negative out, it flipped the x's around, made the 2 into the front. And I'm taking the reciprocal of it, but I have to make sure it's over 1 to not change the value. Just meditate on that, right? Reciprocal flips this, and then distribute the negative in here, it flips them around, and look at this. So these are equal expressions. So it's this multiple of x. Alright, and then distributing the thing there. See how the y2 minus 1 cancels there? So this is really y1 plus y2 over 2, and then I get minus x1 plus x2 over 2 times x1 minus x2 over y2 minus y1. So I just put the 2 over that one and this one over that one, right? It's two fractions. If you multiply them, you get this. Okay. Now again, with this thing, I'm going to do the same thing I did with that. I'm factoring a negative. Out of, well, I'm going to flip it and factor a negative out of this. We'll turn that into a plus. Okay. So, rewriting this, this thing, okay, let's just move on. Okay. Factoring a negative out of here and flipping that, it becomes plus 1 over y2 minus y1 over x2 minus x1 times this thing. Alright, now I have this thing in common, so I'm going to factor the negative of it out, and I'm going to subtract this off. bring it to the other side. So I get y minus y1 plus y2 over 2 equals, now if I factor, before I do that, well, okay. So I just factored that off. But look, what is this? y2 minus y1 over x2 minus x1. That is the slope of the line between the 2 points that we started with. Right? It's the slope of this line. This is y equals mx plus b. The m comes from the slope formula. It's y2 minus y1 over x2 minus x1. That's what the m is for the slope formula. Right? So that thing is negative 1 over m. So if I factor, so I have negative 1 over mx, and I got rid of this, and then here I'm really subtracting the negative 1 over x, so this is plus 1 over m times x1 plus x2 over 2. That's pretty wild. Now if I factor out a negative 1 over m out of this side, I get finally the result that I wanted. So factoring a negative out of here makes this negative, and this is now gone. That is the solution. That's the equation of the object I was after. But what is that? This is now a line in point slope form. The slope has the negative reciprocal of the line through x1, through the 2 points. And this here is the midpoint. So that's an amazing result. And so now we can bring this down. We can still make it bigger. Okay, bring that down like that. That's the line. Okay. So if we start with 2 points, right? Let's see what this set is. So I'm just going to define x1 to be the x coordinate of the point A. So see how I brought the 3 up? I'm going to say that y1 is the y coordinate of the point A. So x2 is the x coordinate, or as the x coordinate of the point B, and y2 is the y coordinate of the point B. All right, great. So now what is this thing? Y minus y1 plus y2 over 2 equals negative, I better define m first. So m is y2 minus y1 over x2 minus x1. It's the slope of the line between these two, right? If I plot this line and then force it to be in y equals, it's got the slope of 1322. If you do 13 divided by 22, you should get 0.59. Okay. So, oops. Alright, so that's what that slope, and we knew that was going to happen. Why did that change? Okay. Anyhow. That's what m is, but now let's do this. This is y minus the y coordinate of the midpoint equals negative 1 over m times x minus the x coordinate of the midpoint. To me, this is just amazing that happened. Look at that. That's just fantastic. Now it'll respond dynamically as I do this. All those points are equidistant from these 2 points. That is just fabulous. And this line will indeed have the negative reciprocal of this. So right now the slope is 0.59, negative 1 over 0.59. Should be negative 1.7, but jangles. Okay. That is just a fabulous little result. And so what the midpoint is, we know that that's the this line here. It's definitely a line. It's the set of all points equidistant from these two, and so the midpoint then is just the intersection of these 2 lines. There. The point C is the midpoint of A and B. That's really how midpoint is defined. And then if we were to, we could prove that this x1 plus x2 over 2, comma y1 plus y2 over 2 really is the intersection of these 2 lines, because we have the equation of basically what is the perpendicular bisector of this line segment, and we easily get the equation of this line from just the point slope form of the line. I mean, all we have to really do is show that x1 plus x2 over 2 with this y-coordinate satisfies this line and this line, and then obviously it's the midpoint. It's both equidistant from A and B and lies on the line, right? So it's relatively easy to show that it lies on both lines. I mean, it obviously lies on this line. It's part of it, right? It's built into it. You're using, if you plugged it in, you just get 0 equals 0. So it's an obvious solution to that line. So to show that it's really the midpoint, all we got to do is show that it lies on this line, and that it is in fact the intersection of the 2 lines, and then we're done. So that's what I'm going to do. So we now have this special little point, and you see what's happening? We're getting that negative 1 over m thing showing up. So it's really tying everything we did together, because these are indeed going to be perpendicular to each other, but there's a little bit more you'd have to show to prove that these lines are perpendicular. You have to show that they intersect at a 90-degree angle. But that is awesome. That's one way to show why perpendicular lines have negative reciprocal slopes. Right? If I took the product of m and this, I would get negative 1. So the negative reciprocals. I just love how it ties it all together like that. It ties the midpoint and the perpendicular line slope thing ideas together just by finding that line. Okay. Cool. So obviously the midpoint satisfies this line. But what's on the other line we have is y minus, and we can choose either y1 or y2 for this. I'll just do y2. This was the other line, right? So this and this should satisfy it. If it does, it's guaranteed to be the midpoint. So y1 plus y2 over 2 minus y2, x1 plus x2 over 2 minus x2. If this is a true statement, we are done. Oh no. No. Don't do that. Okay. So simplifying over here, if I'm really subtracting 2 of these from here, so this becomes y1 minus y2 over 2. And over here, m we know is y2 minus y1 over x2 minus x1. This becomes x1 minus x2 over 2. Alright, so I can now double both sides. And these things are negatives of each other, so they cancel out to a negative 1. But before I do that, I want you to see that these just cancel because I can multiply by 2. these divide perfectly, becoming a -1. Does that make sense? So I get y1 minus y2 equals negative y2 minus y1. Obviously true. Factor a -1 out of there. I get a trivially true result. You can now divide, you can subtract everything from everything and you get a truth. It's true. It satisfies both lines, so it's the intersection of them. And it's therefore the midpoint of the line, because what we have done is we showed that the set of all points equidistant from these 2 points is the perpendicular bisector of this line segment. That's what we just showed. This is the solution to that whole process. And their intersection, we showed, is the midpoint of this thing. It's a nice little result, and it brings the, you know that this is the perpendicular bisector, but we actually haven't shown that it is a perpendicular bisector. We showed that it's a bisector. We know that this point lies on this line, so it is equidistant from these two. But showing that it's perpendicular would be sufficient to show that the perpendicular lines have that relationship happening. But I can show you some other time why perpendicular lines have negative reciprocal slopes of each other. But we know that they do, so we know for sure that that's a right angle, because they have negative reciprocal slopes. The slope of this line is m. The slope of this line is -1 over m. That's the slope of this. We showed that. So they are perpendicular. It's just a lovely little result. I hope that was entertaining, because that's all this was really for.